Right, if you come here for a bit of CB servicing fixing, hopefully we can whet your appetite with this Mustang Cb2000. Now there's a huge similarity between this and the Amstrad 901 in that it has the same board hiding inside it, and they did 3 versions of this: the 1000, the 2000, the 3000. 3000 having some extra width to it with a delta tune. But these are great little radios. Really like the look of these, and Mick said that he quite fancied one of these, and they do come up on eBay from time to time, and this one popped up, so we're going to try and give it a clean up, trying to get rid of some of these nasty scratches in the top of it, and see what we can do there first, and then we'll get it. Well, first off we'll quickly test it to make sure it works before we start any of this, and then we'll see if we can clean this up a little bit and tune it. Right, now someone has drilled some holes in the top of it, but we got some bungs in there which are okay. This has probably been in a lorry or something, I would have thought. So turning it on, that's a good sign that it comes on, a good sign we've got a channel display and the meter is working, because you won't be getting a new one of those off of eBay anytime soon. They often do go in radios, and when you get a scrap chassis they normally are not there. Now another thing I can see here, this knob isn't pushed on properly. There's supposed to be like a little collet on here, and I can see it slid down the shaft a bit. That's all that is. So I'll bring that back up, and we'll pop that back in the right position in a second. So now we're not getting any audio. That can sometimes be because the squelch isn't opening on the test equipment, but we've got the President Randy here. Say hello, and we'll try that on channel 24. Sorry, testing 1 2, and we're not getting anything there. So we're not even getting any signal. So something's not right. So using the President Randy as our monitor receiver, we can see that when we key up on the radio on the Mustang, we're getting the Roger beep. So we know that the radio is transmitting on frequency, it just isn't receiving, and there's no receive coming up on the display of the radio. Now this may be related to something as fairly simple as this PA CB switch. You see here it's actually stiff. I can't actually physically move that. Now I'm not going to try and force that, because if it breaks this switch then I'm in trouble, because unless you've got lots of scrap chassis with the right length switches on, you won't be able to replace that very easily. So we'll flip the lid off of this, and we'll see if we can work this switch free, and we'll see if that brings some life back into the set there, because I know from experience with these sometimes it can be something just as simple as that. Okay, so as suspected, it does appear shenanigans are afoot. I mean, as soon as you know these radios and you see insulation tape and things such as that, when you take the lid off, you know somebody's been in here with a soldering iron. Just looking around, I mean, these are not known for bad capacitors, but this does have a bad capacitor. If you can see down there, you can see how that's receded, the plastic around the top of the can there, and that's either probably from being overvolted. It probably isn't from a reverse polarity condition, because these tend to explode with some force if you do that. I know from experience. And the other capacitors look okay. Radio's a little bit dirty, but there's certainly some evidence of modification work gone on here, which isn't standard. And the nice thing about having a huge collection of other radios is what I can do, and of course all of these screws are broken around here. What I can do is check another radio rather than go to a wiring diagram, which probably won't show the right colours anyway, and I can go to my other working radio and assess if this is indeed wired correctly before I do anything, because it can save you a hell of a lot of time simply by just looking at a working set. And here's your advantage of having a working set that you know hasn't been fiddled with, and we can actually then prop the radios up and have a good look around the pots and the controls to see the differences. Now at first glance I thought that resistor was aftermarket, but it's actually correct. So there probably isn't a great deal wrong actually with this wiring at first glance. It seems to match the radios, although that, that's round the right way and this capacitor is correct. So we'll just have a go first off at freeing up that switch, but we'll get this plate off the front and we'll give this a good polish a bit later on, and we'll get that switch freed up first. Right, so I think we can establish what the link wires are inside the radio there. These link wires here. I couldn't see that with the front cover on, but you can see there's clearly no no switch contacts on the back of that switch, and we've got them on this one. Funny enough, this is something I did see on a Cb2000 recently, something similar, and I actually replaced that. And unfortunately, the back of the switch isn't there for me to repair it, so we're going to have to find a scrap chassis with a switch on. But I do have a little trick for fixing these and making my own, so I might have to employ that tactic if that doesn't work. But let's just look through the bag of scrap that Nigel, a friend of mine, kindly donated to me. You'll often run into problems like this when you're fixing up CBs. The eBay seller will never tell you about things like this, like they've attempted to glue the broken channel knob selector here. Now with this in this position, even glue, it's very tricky to get glue to hold there, even Araldite. I popped the metal clip into the correct place. There was a screw in there which was preventing it making all the way onto the shaft. Now there is a good one off of the good set, and here is the bad one, and there's a difference in size of this. That little crack you can see there is a difference between it gripping and not on the shaft. So what I'm actually going to do with this, because it's probably simplest, is just to quickly 3D print a sliding collar that pushes down around the knob here. There's plenty of room for it to go around in the fascia, which will then grip the outside of this correctly and pinch that onto the shaft, because I just don't think glue is going to hold for very long, even good glue. And you can see how bad this is when I pop it onto the shaft. It doesn't go all the way down. It goes all the way down there, but focus. It wobbles. Okay, so it needs tightening up. Whereas the proper one, I say the proper one, slides down, pushes home, and you don't get any wobbling. So we'll just quickly 3D print a little collar. I'll show you that. It's nothing too incredible, but that's the nice thing about having a 3D printer. When you're doing repairs like this, you can actually manufacture new pieces, and that's a nice well, it's a permanent fix. You can unslide the collar if you want, but certainly with glue, yeah, it's hit and miss. While we wait for that to come off the printer, there's some extremely broken switch activity there, and it appears that they've glued it as well at some point. It's glued in that position, so yes, we'll have to come up with a fix for that. And just 5 minutes later, here's our little ring piece. Now with the collar fitted, no movement at all. That's absolutely solid. That collar's now pinching that nice and tightly around the shaft, so that's a good little repair. Right, now to sort the switch out. We'll go to the box of CB Repair Delights and see if we can find a switch. Now, we found a switch. Two position. In terms of hole size, yep, that looks like it's going to be a match. And what we're going to have to do now is extract the shaft off of this one and place it over that one. I've done this before and it does work. We've done the switch. We've got the original switch shaft, and we've drilled out the centerpiece, and then ground down the shaft of this switch, and then Araldited the shaft back onto it. I've done that on a number of times, and it works absolutely fine. Can't see any evidence of any work being done on this board, but we've got to change that capacitor, and so we're going to clean the board up first before we do that. Just to make sure there are no issues or any problems on the board, and that'll make it easy to spot if there are. Right, that's a lot better now. We can actually get a really good look at that board and see if there's anything that we need to take care of. but I think it's looking pretty darn good, as you can see there. I think we're good to go. So let's remove that capacitor and we'll put it on our little capacitance meter and see exactly how good or bad it is. It's supposed to be 10,000 microfarad. It's showing here at 660. They normally go up and not down in value, and you can see from the how the plastic has receded around here, so you know that's in a bad shape. So it's 1,000 microfarad, I beg your pardon, 10,000 microfarad. There you go. So yes, we will change it. There is its modern day equivalent, slightly smaller. Right now, because we've got a good working set, we can eyeball the connections off the switch in the corner there, and what we'll do, as we can see them clearly, is we'll just make sure that they go into the relative locations on the board, because one thing you can't be sure of is also if you have a scrap set and you use that as your reference for the wiring, there's a chance that that's not right either. So and you can do a lot of damage to these radios if you get some of these wires on these switches in the wrong places. So it's always handy to have a working radio as your reference radio if you're doing repairs on these, because then you know pretty much you're 100% that it's going to be absolutely fine. Alright, we supported the switch above the wires, and we're going to solder it off of the or outside of the radio, then offer it through towards the back of the socket. So we'll eyeball the other ones and we'll get it fitted. Right, so here's what I did with the switch. Because the switches that I've got haven't got the threaded insert on the back of them, I use these little M2 hot nuts, which you normally push fit into plastic stuff, 3D printed stuff. But the advantage they've got over nuts is when you're putting these in, it gives you something to grip on with a pair of long nosed pliers. So I also use this same trick for when you get holes in the case that have someone's overdone, put a bigger screw in and you want to put M3 screws in. What I do is I put these on the inside, the M3 version, and then just araldite them in onto the case, and they're never going to go anywhere, and then you've got a nice threaded barrel for your screw. So these are a great little option for not just obviously doing repairs like this, but for also manufacturing new things and creating threaded holes in plastic inserts. And what we'll do, we'll test the PA function, but before we do that, very often on these chassis it's always wise to give these connectors for the external speakers a good clean with either a pen or some other kind of brush. Never be tempted to use anything too harsh on these connectors, because they're brass plated tin contacts, and what you'll do is you'll actually scrape the brass plate off. So they only just need the top surface taken off. And what you can also do once you've done that is what I sometimes do is just give them a little puffer switch cleaner as well, and that also keeps those horrible little fibres at bay, as they get in your fingers, they do. So our PA CB function switch now works correctly. We can pop this into PA mode, which it's in now, and test the audio. 1 2 1 2. So that's a good sign. We now know that the audio IC is at least okay, but we've still not got in CB mode. We've got no noticeable squelch. Now what we'll do is we'll just see again if we've got a digit missing there, so we'll have to give that a clean. We'll just see if we can pick anything up on channel 20 with our handy President Randy, and no. So we're not picking up anything on the President Randy, and but we are transmitting. 1 2. There you go. You can hear that's coming in off the Randy. So we're still in the same situation that we were, but we've now got a capacitor, which isn't bad, and we've got a fully working PA CB switch. We've just got to find out why we're not getting any received audio from the radio section. Right, looking at the subsystem chip, we've got our receiver signal coming into the input of the subsystem chip, the LA1230, but we're not getting any output coming out the other side of the subsystem chip. And we should on pin 8 be getting a square wave on the healthy radio, and we're not getting that on this. So I suspect that the source of possibly an overvoltage has caused some damage to the subsystem chip on this one. So if I've got another radio I can take one from, we should be in business. If not, I think we'll have to drop onto eBay and try and get one. Luckily I've actually got an old Amstrad 901. This is the Hong Kong variant, and this one's been modified and had all sorts done to it by somebody else, and it's a little bit noisy in reception and on transmit. So I've decided for now we will take the subsystem chip out of this one and swap it into this one. Right, we've now changed the subsystem chip, the 1230. Here's the moment of truth, the SIGGEN is on. There we go. We've got the S meter working as well, which wasn't working before. So I suspect the reason for that capacitor going as it was because this was overvolted, and the overvoltage took that out. So there we go. So the subsystem chip was the fault on no receive. So we should now, having cleared all the hardware faults, be able to actually tune this up and present it to Mick once we've polished the front of it. There we go. And we've got 2.3 volts. And then in transmit we're looking at the same at 2 volts. Now that to me looks absolutely fine. And then what we do is we change channel to channel 40, and then on channel 40, according to the manual, we're looking for 4.5 volts. But I know these are okay if they're if they're under that. We've got 4.2 on receive. Right, the memory card ran out on me there, but anyway, the VCO is absolutely fine. So now we're going to just do the transmit power, okay, which is this section here. I'll stick it on channel 20. We're on the middle scale there, and we're doing about 3.8 watts, it's looking like. Okay, 3.8 watts. So we should better bring that up to just over 4 with a little bit of tweaking. So let's grab a tool and see how we can improve on things. Alright, let's just tweak these up. Okay, we shifted it a bit. Oh yeah, that was worth doing. There we go. Bang on 4 watts, Mick. We will check that on the spectrum analyzer later. And that's got your Roger bleep as well. And what we will do, not that anyone probably uses it, is we will set the low power setting and see what we're doing on that. And we're doing 0.4 of a watt, absolutely spot on. So that doesn't need any adjustment, although I don't think there is any adjustment on this one for that. Right, we'll now just give the little pot there a little bit of a clean for the RF power meter adjuster. And let me find my yellow stick. But to be honest, checking that, that's okay. We're doing about 4 watts, and somewhere just into the strawberry patch is good for me. Alright, sorry about the camera angle. We'll give it some beans then. We'll use the little tuner and get a tone going. We'll see what we're doing here. Goodness me. It's a little bit high, isn't it? Let's just wind that back a little bit. Let's bring it down to, that's 2.5 with the tone on. Okay. 1, 2. 1, 2. 1, 2. Yep. That's okay. And before we move on to receive, the last thing to check for Michael here is the frequency, and that is adjusted on this L2 inductor core here, and that's your reference crystal for your VCO. So let's just squint at the SDR while I'm doing this. I think it's going to be there or thereabouts. Right, the maximum we can get out of it is 27,79118, which is very close. That makes no difference. I will keep an eye out for another reference crystal though, to see if we can perhaps bring that up a little bit if there's any issues, but that's as near as makes absolutely no difference and is well in spec. Okay, so on receive, this is already absolutely cock on. It's we're listening to 0.4 of a microvolt there for 12 decibel synad, which is very, very sensitive, considering I don't think anyone has touched this. So yeah, we could certainly have a go at bringing it down a little bit more, but we'll probably, there's a possibility we might make it worse. So I'm sort of reluctant to do this when they're like this, because you can also do things like break cores in the inductors and things like that, annoying things. So for the sake of just getting a few extra microvolts, but we'll see if we can bring it down a tad. So we're doing 0.4. Let's see what we can do. Okay, so we're going to start off with this one, and this one, and then we'll do the detector. Although it's possibly better to do the detector first. So I'll just quickly do the detector off camera, and then we'll come back and do the front end. Right, we've peaked the detector. That's peaked. So let's tune it up. Right, I won't expose you to too much of this noise, but we're doing 12 decibel synad, we're doing 0.5 of a microvolt. So I'm going to start off with this 1, 2, 3, 4, 5, these IFs here, and we've already done the detector. So let's see if we can improve on 0.5. The answer to that is very marginally. We're now doing for 12 decibel synad 0.545 of a microvolt. So we're slightly better. So the only thing to do now, we've done the S meter. The S meter adjustment is an RV2 for 100 microvolts. So we just need to do the squelch. So the squelch potentiometer is RV5. I've already given that a bit of a squirt. I tend to do that with all of these on these older radios and give them a wiggle just to give them a good clean. Right, I think I got this about right. So 70 microvolts, 79 microvolts it comes in, and it leaves at 70 microvolts. That's a good compromise, because it should bring the low end up. Comes in at 0.3, leaves at 0.1. So that's sensitive on the low end, and good enough for jazz on the high end. Right, I think that's pretty much it. So all that leaves us to do now is to just clean up the knobs and the fascia, give the case a good wipe down, screw it all together, and then see if we can raise Mick to test his new radio with himself. Right, it's all screwed back together. We've sorted all the problems out. The dodgy switch on the PA, the channel selector knob obviously, and the digits, and then the dodgy subsystem chip, which was giving us no receive at all. So anyway, let's see if Mick is around. Right, this is Secret Squirrel. Are you around bus stop for a quick radio check? This is the new repaired Mustang Cb2000 doing 4 watts. I wonder if you could start recording your end, sir. Field.
Yeah, this is bus stop this end, talking to the Secret Squirrel. And yeah, it's running now, so it's video recording. So let's see what it does.
Okay, so what do you think to this then? This is the Mustang Cb2000 that we repaired.
I think it had been overvolted at some point during its life. It got a very poorly capacitor in there on the main power supply incomer, and it's got a very poorly subsystem chip, I think from the result of that, an LA1230, which normally you could not get, but I sacrificed an old Amstrad 901 just to get your radio up and running.
the Amstrad 901 wasn't particularly good, so it was not much of a sacrifice because it was the Hong Kong variant of the radio. So yeah, I just wonder what you think to this. It's certainly working fine, and it's working much better than it was when it arrived this morning, Rog.
That sounds very good, Paul. It's nice audio on it, I must say. It sounds nice and clean. And you've got two pounds on the meter, you know, and yes, I was pleased with that. So, oh, you say you thought it had been overvolted. Oh, okay.
Okay, with that we'll clear, and we'll say thank you to the viewers for watching. I hope you've enjoyed this repair. It was a little bit more drastic than most of them often get, but sometimes that is just the case. It's like a box of chocolates, you just don't know what you're going to get. Okay, if you have been, thanks ever so much for watching. Me and Mick will catch you on the next one. Have a great weekend, everyone. Goodbye.